Hello guys, how are you doing? Let me quickly introduce myself. My name is Uma Shankar, currently working as a DevOps engineer in retail business banking sector. As I got lots of spare time for the past couple of weeks due to Christmas break, I have decided to spend some time setting up a cluster, EKS cluster, and do a quick experiment with persistent storage with Kubernetes. I'm planning to make a very short video, possibly less than 20 minutes, at the same time covering most of the recent technologies. Hence, I will not cover the process of prerequisite installations. All the command line tools used in this demo are freely available to download with the detailed installation instructions online. So I don't want to waste time going through installations. This video is intended mainly for someone who got a very basic knowledge of Terraform and Kubernetes and want to explore with EKS and persistent storage. So let's get going. Basically, you just need an AWS account, an active AWS account with admin user access. And the costing would be something like, because AWS is going to charge for using EKS clusters something around 10 cents per hour. It might cost you around $3 to run this experiment, but for me it cost me around $18 because I've been using EKS and EC2 instances for the past 3-4 days. If you have a free AWS account, then you might get free EC2 instances if you are using micro size instances. In this demo, I think we'll be using small and medium EC2 instances. Okay, and apart from AWS account, you need to have some command line tools installed. Basically, I'm using Ubuntu virtual machine, which is installed on my, which is set up on my MacBook. It's up to you guys. You can directly install the CLI tools on Mac directly or on your Windows system, or you can set up EC2 instance on cloud and then install these tools. So let me check what versions I have and what is the list required. AWS CLI is required, and let me check what version I have. AWS version, that is 2030, and we need a kubectl. It takes some time to get response back from kubectl. Come on, here you go. And we need Terraform as well. And finally Git. So you don't need to exactly have the similar versions, as long as you need Terraform. If you have Terraform 0.12, you should be fine, and one of the reasonable versions of kubectl should be fine. And AWS, I think you at least need a version 2.0. Okay. Yeah, going back to AWS account, so you must have access to AWS admin user. And in terms of the privileges, what I have done is I have set up a common user, and I given it as an admin access. So I'll show you the user setup, which is using for a Terraform. So I have created a user called InUSR Terra, and then using the same user in AWS configure. So you need to configure that user, admin user, in your development box where you are actually going to run these command line tools. Okay, so that the Terraform is going to use the same user to apply the resources in the cloud. Okay, if you don't have you can pause the video here if you want to install any of the tools, and then carry on later. Okay, welcome back, guys. I hope you have installed the command line tools required. So, firstly, what I'm going to do, I'm going to clone my Git repo, which is basically the link is provided here in this video. So, just need to code copy and then git clone. So, once you've done this, all the code will be downloaded into your local system. So, I'm not going to execute this command. I already have code copied on my system, so I'm going to use Microsoft Visual Studio Code basically as an editor. Okay, here we go. So in the directory structure we have two directories, K8S and TF. As the naming convention explained, TF will have all the Terraform files and K8S will have all the support files for Kubernetes where we need to execute them. I'll go through K8S files later. To start with, let's go through Terraform files. Okay, and we'll go from top to bottom. Backend.tf is nothing but where the Terraform state files and Terraform backup files are stored, right? So for example, if you run Terraform apply after Terraform init, right, and all the Terraform states files will be copied in S3 bucket. Okay, and this is the name of the bucket, and you don't need this backend file. You can delete this file. Even then, that this code should work fine because the Terraform state files will be stored locally. Okay, and EKS cluster.tf, this is basically a module which is already available widely open. This is the Terraform EKS module provided by HashiCorp. So this file you can actually define how many worker nodes for EKS cluster you can define, whether you can go for one node or we can go for multiple nodes. So I have defined we have defined here two different security groups and two different size and different size of nodes. One is small and one is medium, hence we have two different security groups here. Okay, and we can change the number here if you want to number 2 or number 3, whatever it is. So many worker nodes will be created. And the main advantage of EKS cluster, defining EKS cluster, is the master node will be created by EKS cluster itself. We don't need to worry about master node. Okay, in generally, if you are creating Kubernetes cluster without EKS, you have to define everything, what is the master node and what is the size of the master node and how many worker nodes you need and how they are connected and what VPCs will they be using, subnets and all blah blah. But with this EKS module you have everything predefined. Okay, so that makes life easy. Okay, so that is the one of the main reasons we'll be using modules here. So it's a straightforward. Okay, and it's the parameters supposed to be changed in this are very less. Okay, and Kubernetes file, there is nothing we can change here. It's everything is in order. So it's just downloading the provider along with it's using some of the data which is being outputted by Terraform output files, which I'm going to talk about here. Okay, and outputs, the TF file will have all the variables which we are going to use further down the line. Once we have created a EKS cluster, we might need to know what would be the cluster ID, and that cluster ID will be configured in kubectl. So we need to have all these output variables, and that will be stored in as part of Terraform output variables, right? And security groups, as I mentioned earlier, we are going to use two security groups, and the VPC defined here is going to be coming from vpc.tf file. So this is normal security groups file. You can change the ports, ingress ports and outgress ports here, but this is a standard security groups tf file, right? And versions.tf, um, in this file we are going to define what are the modules required, what are the providers required to execute this Terraform EKS cluster. Okay, these are all defined here. So and the last one vpc.tf. So this is again we are using vpc module, which is available on hashcorp registry. So we are not doing from scratch, we are not creating vpc from scratch but we are going to use the vpc model which is already available, and the parameters is clearly defined here. So what are the parameters required to create an vpc? So the name of the vpc you can change it if you want to, and then which region you want to generate, which region you want to set up this vpc, and what are the ip addresses of private subnets and public subnet, blah blah. So you can change this, but this is the standard values here. Apart from the name and then CADR, you don't need to change anything here. Okay, so I hope everything is fine so far with the Terraform. um, so going further, so once we clone the repo and we have gone through the we downloaded, so let me go to the directory where we have this downloaded. So cd, so we have all tf files here. So you basically the first command, I'm sure most of you might aware of already about the terraform init command. So terraform init command is going to initialize and download all the modules required along with the providers. Okay, so this is going to this code, terraform init is going to download all the required modules and the providers, and it's going to initialize the backend as well, and you don't need the backend file as I explained earlier. So this command is going to take some time, and that's why I have already executed terraform init command, um, and downloaded all the modules and providers required. Okay, so this command is just going to check now because it's already downloaded. It's going to check whether they are available or not. So dot terraform, you can see here in the Visual Studio Code. So we have here modules downloaded, EKS and VPC, and all the required plugins will be downloaded as well. Okay, so you can see here terraform successfully initialized. If you're doing this first time, this might take you at least 10 to 15 minutes, because we are doing a short video. I have already done the initialization. If you get any errors during initialization, some modules might get timed out. You keep doing terraform init command until you get this terraform has successfully initialized. All right, so going further, let's go to IAM AWS console before we actually create EKS cluster. How is the dashboard is looking like? So if you look at services and then EC2 dashboard, I don't have any instances, I don't have any load balancers. Okay, I have only one volume, right? And I'm going to create now EKS cluster. If you go to check whether there are any existing EKS cluster as well, but before we create EKS cluster, so EKS Elastic Kubernetes Service EKS, right? So there are no clusters available here. Okay, so now it's showing as blank. Now I'm going ahead and then apply Terraform. There are several other commands you can do before actually apply, but this main this is basically this exercise is to shorten the video, so I'm going to directly apply Terraform apply. Right, you can do Terraform plan and then see how many resources are there, and then so that is a standard process, but I'm going to do Terraform apply directly. I'm going to pause the video here because it is going to take at least 20 to 25 minutes to actually create the complete cluster, Terraform cluster. Okay, so I'm going to pause the video until all the resources in AWS cloud are generated. Once it is executed, I'll start the recording and then we can see what are the resources generated. So Terraform has actually calculated, gone through all the Terraform TF files, and then it's actually going to ask for confirmation how many resources it's going to create, and it's going to ask for confirmation. So you have to press yes here, and once you press yes, again it's going to take some time. So I press yes, I actually enter yes, and then again pause this video. Okay, so Terraform apply has now finished, and you can see all the output variables which we have defined in outputs.tf file. It's been showing in green color, so you can see how many resources are generated. So total 49 resources have been generated, like subnets, VPCs, security groups, worker nodes, including the EKS cluster. So let's go through AWS console again now. So I'm going to refresh this EKS clusters. So how many clusters we have created? You could see here one cluster has been created and it's in active state. So the name of the cluster is test EKS cluster. And if you go through EC2 dashboard, so we have two instances created as a worker nodes without any master node for Kubernetes. And you can actually see the names of the clusters, names of the worker nodes as well. We don't need to give any names. It's all automatically picked up as a suffix of as a prefix of EKS cluster name. And going back, it should have created two more volumes. So yeah, there was already one volume before we run this command, right? So we have now three volumes, and it generated two volumes, each 100 gig. This has to be configured somewhere in EKS module, TF module itself. We can change from whatever you like. You can change it to 20 GB or 30 GB, but these are volumes required to maintain the Kubernetes clusters. Okay, so these two are generated already by the EKS module. Okay, so now we have EKS infrastructure generated. The next step would be creating configuring kubectl with the EKS cluster which has been now generated. So in order to do that, we just need to run AWS. We can do that using AWS CLI. So the using the output variables from Terraform, I'm going to just write down the command. Uh, you can actually copy it from the Terraform output as well, but I'm just going to use the variables and then update. So these two output variables, we are going to use Terraform output variables. As you could see, the context of kubectl has been updated. Now you can run kubectl get all command. Basically you can get the cluster IP. Yeah, and this is basically going to respond the output of kubectl get command would be just for the default namespaces. If you want the output for all the namespaces, then you can just use all namespaces. Yeah, so that is the output we have seen here. We have created kubectl kube system namespace and the default namespace. Right, the next step is we need to set up a metric server for Kubernetes. So metric server is nothing but it actually aggregates the data and collects the data from Kubernetes cluster from all the resources like services, replica sets, pods, uh, persistent volume claims. So from all the components, it collects the data, it gathers the data, and we need to deploy on dashboard on top of the metric server to actually see the web interface of the metric server. So um, I have actually copied the URLs in README file of both metric server and dashboard. Um, at the moment of recording this video, the metric server latest version was 0.41, and dashboard was 2.10. And you can always browse this repository on GitHub. This is official, a repository for a Kubernetes metric server, and then get the latest version, right? And you don't need to download anything. You can directly apply um, directly using that URL. So I'm going to copy the URL of the metric server. Okay, so as you could see, it's been created. It's created the new namespace as well, along with the service account, right? And the next step is to create a kubectl dashboard. Again, the URL is here. Okay, so now the metric server and the dashboards are available. Before we actually browse the metric server with the dashboard, basically we need to create a service account which can access the namespace of Kubernetes dashboard. And after that, we need to create the role binding as well. So these two files, YAML files for creating a service account and role binding, are available in K8S folder in the repository. So I'm going to create service account first, and then followed by role binding. Yeah, service account has been created, and at the same time we need to create a role binding. Okay, so now we are ready to browse the dashboard, kubectl dashboard. um, for that, we need to open kubectl proxy, which actually opens up 8001 port, and we can access the dashboard through one to through localhost 8001 port. The URL is again in readme file. As you could see, we need to authenticate the dashboard. We got the load dashboard has been loaded. Now you could see there are two options to log into dashboard. One is using the authentication token, and other one is the kube config. We need to get the configuration from local host, but the best way to do here is the using the token. So let's get the token for kubectl namespace, for Kubernetes dashboard namespace, and the token command is here. So we have to be very careful here in this command. There are so many people, they use like Kubernetes instead of Kubernetes dashboard namespace, they have used kube system namespace. If you get that token from kube system namespace, you can't get full access to the dashboard, so you'll get so many errors in the dashboard, and the dashboard won't work properly. We need to keep this proxy terminal running, so we need to open a new window. Right. Okay, we got the token, and copy this token and paste it in the dashboard. This might be from my previous tokens, so I'm going to delete that and paste the new one, and click on sign in, go update. Okay, now you could see the dashboard has been loaded. So this is a very interesting interface where you can actually see all the workloads and services and the storage configurations. Everything will be listed in this dashboard. So if you look at deployments, we have not done any deployment yet, so you can't see anything here, and even pods as well. We have not deployed any pod or replica sets, but you can see some default, like there will be some default services which already comes with Kubernetes cluster. Apart from that, this would be generally blank, but we are able to load the dashboard. So going back to the Kubernetes files, what we are going to do after setting up EKS infrastructure and then setting up a Kubernetes dashboard, we are going to do a quick experiment on creating a Kubernetes deployment with two pods. One is with with persistent volume and without persistent volume. Let's start with without persistent volume and what happens if we delete the pod, and then see what happens, right? And for this deployment, what I'm going to use a artifactory image. This is just like anything, I'll create an artifactory. This is basically if you can search on the internet, the image has been pulled, like at least this is one of the famous artifactory images available on Docker registry, Docker Hub. So if you look at it, so it has got almost, yeah, if you look at it, it's got almost 1 million plus pulls. And this is one of the simple implementation of artifactory, wherein it has exposed a few data directories, like any artifacts uploaded into artifactory of this image of this Docker container will be loaded into data, and the logs will be loaded into logs directory, and similar to backup. So we are going to create a we are going to use this image in Kubernetes stack. So basically, if you look at this file, it has got the first section is a service which is exposing 8080 port, and I'm going to use the service type as load balancer. Load balancer basically creates an external IP address for this service, so that you can browse from outside world. Okay, if you want to create a service which is something like which you don't want to give URL access to outside world, then you need to go for cluster IP instead of load balancer. But for this exercise, we are going to use the load balancer. We will to get access to the URL, and I'm going to create two pods within the replica set, and and the name would be, this would be anything, but the main thing here, very important, is the selector app match labels is supposed to be AF. So the service is going to look at this and then match to this pod, right? Let's apply. So kubectl. This is going to create a AF service along with the two pods and the replica sets. Once it is done, we can actually browse through the dashboard, right? So now opening up the dashboard, you can see here the workloads. In the workload section, you can see the deployments, pods, and replica sets. So deployments, we have one deployment still pending going on, and pods are, so at this time So the Kubernetes will be pulling up the Docker image and then creating the instance. So now it's already done, and you can see the replica set, one replica set. Right now everything is there. So if you go to service here, as I mentioned earlier, if you go to services, you can see the new service AFSFC with the external IP address. Right, if you click on this URL, it's going to open actual the service, the Artifactory service itself. Yeah, I could see the Artifactory is now loaded. This is using the external URL which is provided by the service in Kubernetes cluster. Now let me log in. So the default username and password, which is admin and password, I'm just going to log in. You can change it if you want to, but this is only a test instance, so we're going to trash it once we have used it, so I don't mind using it, the default username and password. So let's say don't save. Now let's go and deploy some artifact and then see what happens if we stop the pod, whether the data which we have uploaded exists or not. So let's deploy this. Deploy one of the jar file. I'm just going to browse downloads. Is going to deploy into ext releases local repository of this Artifactory instance with this directory structure info qx gherkin on the stuff, and I'm going to deploy artifact. And that's it, successfully deployed. Now if you look at artifacts, you could see there is a new artifact in this info and everything. Right now, so now we have some data in this artifact instance, and what happens if one of the pod or both pods go down, and whether this data exists. So for some reason in your production environment, if the pod goes down where this holding the data, right, we have not exposed any, we have not used any persistent volumes yet. So if you don't use persistent volumes, that means whatever the data used here as uploaded here is going to be not guaranteed if anything goes wrong with the pod. So let's stop manually. Let's stop these services, kubectl get all. So we have two pods running and one service with external IP, right? So let's don't touch the service and just stop the pod itself, both pods itself, right? If we stop the pods, because of the replica sets, it's going to start themselves again, but the data should be lost. So let's try this. Delete pod. So one pod has been deleted, and I'm going to delete another pod as well. So another pod has been deleted. Let's go to the dashboard, and what's happening here, you can see the workloads. Refresh the dashboard and go to the pods. So you could see there are two new pods have been created already. So by the time we stopped, we deleted and we came back to the dashboard, it's already created two new pods. Because of the replica set, it's been always keep checking as per the requirement. So in the definition we have given two pods should be running for this replica set. So the thing here is, if you go back to this external IP, to this artifact instance, whatever the data which we have uploaded into previous version of the previous pod, because we have deleted those pods, and this data should not exist, right? So if I refresh, you could see the data has been deleted. That means this is just I have taken only one artifact as an example, and assume that you have thousands and thousands of artifacts in this artifactory, and by chance you have there is an instance where you have to delete all the pods, or the pods have been crashed for some reason, then you lose all the data. So if you don't use persistent volumes, then you lose all the data. Now coming back to the Kubernetes files, coming back to K8S files, we have another example where we are going to create Artifactory service, Artifactory stack, AF stack with persistent volumes. Okay, so first we need to understand the concept of storage class, persistent volume, and persistent volume claims before we actually deploy this file, right? So what is a what is a persistent? Uh, let's go from storage class. So in AWS, a storage class is mandatory to create a persistent volume or persistent volume claim. Without storage class in the latest versions of Kubernetes or EKS clusters, we can't create. So storage class defines the parameters of so many policies of the persistence volume. Okay, whether do we need to retain this do we need to retain this volume, or do we need to bound immediately? And there are so many other properties which we can define in storage class, and we have to give a name for a storage class where this storage class is referred in that persistent volume and persistent volume claim. Okay, storage class is the mandatory to create in AWS especially. Okay, and persistent volume is nothing but we should have already EBS volume created in order to use the persistent volume. So this block of code, what it does do is it actually uses the existing volume using this volume ID, and then create and then pair the volume with the cluster. Okay, so persistent volume, it does not create any new volume, it is going to pair existing EBS volume with the EKS cluster. That's the main purpose of persistent volume. Okay, and persistent volume claim, that is the last element here, is nothing but persistent volume is something like it's like claiming. So I have got 10 gigabytes in a persistent volume, and I'm going to claim, for example, 5 gigabytes from this persistent volume, right? So all the parts, they can only pair with persistent volume claims, they can't pair with persistent volumes. Okay, so that is the main reason we have to create these three Kubernetes elements: storage class, persistent volume, and persistent volume claim. You can create one by one and then do it, but actually I have defined all of them in one file. Okay, so going back to the another YAML file, this is another one which actually creates the service, just like which we had done the AF stack earlier. This is going to be creating another stack, right? But it's going to create another service with I have given different name to make sure that I'm not going to delete the existing service, existing deployment, but I'm going to do a new service and new deployment, right? And in this deployment, the difference between the old one and this one is we are going to use the volume mounts here. Okay, this is where we have defined here. If you look, as I mentioned earlier, we are going to only pair the pod or the deployment with PVs, with the persistent volume claim, not the persistent volume. Okay, and that is the only difference. And the directory, right, the directory is going to be the artifactory.data, as I shown earlier in this Docker image, right? I'm going to expose this directory from the Docker container, okay, on the pod. And you can do multiple things. You can do three directories like data, logs, and backup, but just for this exercise purpose, I'm just going to expose only one directory, data directory. And subpath is also very, very important. Kubernetes cannot write directly onto EBS volume. It has to have a subpath. That means in EBS itself, it is going to define a new path, NES or underscore AF, something like that. You can give any name, but this is a mandatory. So it is whatever is the data it is going to map it to, it is going to map to the this directory inside the volume, right? And going back to the AWS, I have already shown you we had one volume already created earlier. so which is 10 gigabytes volume. Let's delete this volume and create a new volume. So get the volume ID, and I'm going to delete this volume. Okay, so the volume has been deleted from the command line. Let's check on the interface. Here you go. So the volume has been deleted. So I just want to make a fresh start of the volume creation. So I deleted the old one. So create a new one with the same okay, US East. So the same region as the existing volumes. So I'm going to create a new one. AWS EC2 create volume. Okay, the volume has been created with the volume ID and all the parameters. We got it here. So we need to use this volume ID in our Kubernetes YAML file. So I'm going to use copy this and then use this in PVC. This is the place which we are going to use. Save it, and you can actually see the volume is, if you refresh this page, you will see 3 volumes, one with 10 gigabytes. Yeah, got it. So now let's apply. Now we are ready to go and create before we do, let's see in the dashboard whether we already have any persistent volumes or persistent volume claims. Okay, so now there are no persistent volumes claims here, and then we have there are no persistent volumes, and even the storage class also you can see storage class, this is the default one. Once we create the one which is required for AF Artifactory, you'll get the new one. So let's apply kubectl. Check the file name AFSCPC. Okay, so we have here storage class created, persistent volume and persistent volume claims, and you can actually see here kubectl get PV means persistent volume. Yeah, so we got PV and which is in bound state, that means it's already bound to the PVC, and you can actually see kubectl get PVC and kubectl get SC. Okay, and let's refresh the dashboard now, so you could see the new storage class and persistent volume claim. These are the and then the persistent volume, right? So everything is in place. Now we are going to create again AF stack. So the AF stack here, this is the one, and please note that we are not going to create multiple pods here. We're going to create only one pod. I'll just explain it, the reason behind it later, but for the moment we are going to create only one pod and then upload and then open the URL Artifactory and then try to create some data inside the pod and kill the pod and start it again, so that we retain the data. Let's apply again. Okay, now we got the new service created. I just renamed them for differentiation purpose. Something with PV. So the service for the new is going to be AFSVC PV, and then AF PV deploy. And in the dashboard also they reflect the same. The workloads. If you go to workloads, so you could see the new pods has been created just 51 seconds ago, right? And we have a new deployment as well, and this is with persistent volumes. So let's open the Artifactory instance of the new service which is created with persistence volume. So as we see now, you can see here, this is the service which is created AFSVC PV, and I'm going to click on this URL, which this is the URL of the old service and this is the new service, right? So here you go. So we have the new instance of Artifactory. Now we are going to do the same routine. We're going to deploy an artifact. Again, log in with admin. So admin password, and we're going to deploy the same Gherkin artifact. Gherkin. You can choose any repository here, but let me stick with ext local, release local, then deploy. So successfully deployed. In the artifact section, we have artifact being deployed here. Now I'm going to stop this pod which is running with persistent volume. uh, when we stop the pod, it's going to um, create again, but the data should not be lost. So the artifact which we have uploaded, it should be still there, and then it should bind to the same pod with the persistent volume. So let's try that. kubectl get all. um, this is the new service created, and the pod here is PV pod. So I'm going to stop this pod. Okay, the pod has been deleted, and let's go to the dashboard and then see whether it's a new pod has been created already. Yeah, so you can see the new pod has been created 23 seconds ago. It might take some time to mount with the persistent value, and then once it is done, then we can actually see the artifact already exists or not. So this is the one which this is the Artifactory instance, right? I'm going to refresh. It might ask you to log in because it's a new pod. And then go to artifacts. See, you could see the artifact already exists. That means the persistent volume, the experiment which we did, without volume we lost the data, and with persistent volume we actually retained the data from artifact instance. Okay, so I think we are almost at the end of the session. So before we go, I just wanted to let you know there is a disadvantage or a limitation with Kubernetes persistent volume. As I mentioned earlier, we have used only one pod, one replica instance here, right? One pod in this replica, because the mounts in AWS, it can only mount to one pod. So that was a disadvantage. So if you want to use the persistent volume connecting to multiple pods, then you should go for something else called NFS storage. I'm not sure whether AWS supports it NFS storage, but Google Cloud supports NFS storage. But yeah, so you have workaround. I think you have workaround in even AWS as well. So so this is that's all. So we are now done with our experiment, and before we go, we just need to make sure we need to destroy all the resources created in AWS before we log off. So um, in Terraform, we'll be just going to do Terraform destroy. Okay, so this is going to delete. So this is not the right way of doing, but in conscious of time, so we are going to first delete all the resources, and anything left on the AWS console we'll delete it. Ideally we should delete Kubernetes services and the deployments and then go for the resources, but we're going to destroy directly the resources, AWS resources. Okay, Terraform is going to ask for confirmation again, so I'm just going to say yes and press enter. This is going to take some time, so I'm going to pause the recording. Okay, Terraform has done its job, so it's deleted, destroyed all the AWS resources. Let's see the dashboard. So you can see instances here, it's been terminated, and the load balancers won't be deleted because load balancers were created by Kubernetes services, so we need to delete them manually. Um, so delete, and the Kubernetes EKS cluster also should have been deleted. Yeah, here you go, it's deleted. So yeah, so we are done with our exercise, or whatever you call it, experiment. So um, have a good Christmas, guys, and happy New Year.